Hi class, this is 18.4. We're going to be finding missing angles with trigonometry. So trigonometry, remember, helped us in the past because it allowed us to relate two sides of a triangle to an angle measure. And it had to be, of course, a right triangle, but it allowed us to find sides. Today, we're going to be finding missing angles with trigonometry. So you'll notice with these problems here, the first problem, example 1 and 2, I'll put those up. You'll note that it is now the angle that we don't know. All right, so that's a little bit different than not knowing the sides. So if it's the angle we don't know, then we have to use what we call inverse functions. And inverse functions allow us to, what's going on? Inverse functions allow us to find the angles. So on your calculators, I don't really have my thing up to show you, but on your calculators above the sine, cosine, and tangent, if you'll look at your calculator, you're going to notice that there's a sine inverse, a cosine inverse, and a tangent inverse. It has like a little -1 up there, and that -1 allows you to figure out that angle with the sides. So we're still using trig functions. We're still using the O, A, and H. We still have to label the sides. So to find angles, I'm going to actually pull this up so that you can see on the calculator what I'm talking about. Let me just pull this over if I can. Pull this over here. So you notice on your calculator, here's your sine, cosine, and tangent. The sine inverse right above it, cosine inverse, tangent inverse right above it will allow you to figure out what those cosine, sine, and tangents are. So for instance, if I know the ratio of sides, say, is 5 over 6, I can actually do second sine inverse and then 5 over 6. So sine inverse, I didn't hit sine inverse second. I thought I did. Yeah, sine inverse 5 divides 6. So if I'm looking for a sine inverse with this ratio of sides, opposite over hypotenuse, opposite side over hypotenuse, and I use the sine inverse, when I hit enter, I'm going to get an angle. It'll be an acute angle, something less than 90, greater than 0, but in this case it's 56 degrees. But that tells me the angle if the ratio of the sides happen to be 5 over 6 of the triangle. So missing angles with trigonometry. What we're going to be using now, let me get my marker here, are sine inverse. Now sine is opposite over hypotenuse, remember? So it's sine inverse of opposite over hypotenuse is equal to our angle. Cosine inverse of adjacent over hypotenuse, the ratio of the adjacent to the hypotenuse sides, is equal to our angle, and tangent inverse of opposite over adjacent is equal to our angle. So what we were saying before, for steps, the first thing you're going to have to do are find or label O, A, and H, and then find your which of the inverse function we are going to use given the O, A, or H, which are the two sides we have. And then you're going to write the equation, and you don't have to solve these. There's no solving. You just place in your calculator what you have. All right, so it's the same exact steps before. It's just you don't have to solve anymore, which is really, really nice. So we locate the angle. We have the angle here. It's angle x. So x degrees is going to equal, and this is our little equation. I need to look at my sides. 9 is opposite, isn't it? It's opposite the angle, and then 20 runs right into the angle, so it's adjacent. So we have O and A, which is tangent. So we'll write tangent inverse, since it's the angle that we're looking for. And then opposite over adjacent is 9 over 20, 9 divided 20. All right, tan inverse 9/20. So I'm going to plug this over here. We're going to look at our calculator. Where is it? Here it is. All right, so we'll do second tan. So second and then tan. And I think it was 9/20, 9 divide 20. And angle measure then, x degrees is 24.2 degrees. All right, so that's how you'll plug that into your calculator. So x degrees was 24.2 degrees. Usually on degrees, I would say about 24. I usually just like to round on those. All right, so same thing, but this time we're using our inverse function, sine inverse, cosine inverse, tangent inverse, and we're just putting in the ratio. No need to solve or anything, which is really, really nice. Okay, so here again we have an angle. This side we're going to label, it's adjacent, it runs right into the angle, and then this side has a 32 on it, it's the hypotenuse. All right, A and H is cosine. Cosine. So COTOA, that's another thing I would write down. Always know that little acronym to know which of the two sides each of the trig functions relate. So cosine relates adjacent to hypotenuse. So cosine inverse, since we're looking for an angle, is, it's x degrees is equal to cosine inverse of adjacent to hypotenuse, 17/32. Is what we'll have now. I'm not going to actually pull over my calculators. I think you guys got it now. Cosine inverse 17 divide 32, and that is 57.9 degrees, 0.910, so 58 degrees is approximately what 8x is. All right, so not too bad so far. Where's my... Whoops, I did not want to do that. Okay. All right, next two, we have the angle here, x degrees, and we have this side which runs into the angle, so adjacent. We have this side that's opposite the angle, O, and this is going to be tangent. So x degrees will equal tangent inverse of opposite divided by adjacent, 13/18. And just placing that right in the calculator, 13 divide 18 is 35.837. So 35.84, which is approximately 36 degrees. All right. And then lastly, we have our angle here, x degrees opposite is 21, so that's opposite. And hypotenuse, right? This is hypotenuse because it's right across from the 90-degree angle. So we have O and H. O and H is SOHCAHTOA, so it's sine. So we'll have sine inverse. X degrees is going to be sine inverse of the opposite to the adjacent, which is 21 divided by 28. Okay, so second sine 21 divided 28. It's 48.59 degrees, so I'm going to say x degrees is approximately 49 degrees. Okay, usually on degrees we do just go straight to the angle because then we have to cut it down by a lot of other things like degrees and minutes, and it's not as easy. All right, find the measure of angle CDB. So, sorry, I had to get a drink real quick. So, the measure of angle CDB. Oh, no, I did not mean to do that. I just wanted to move down. So, measure of angle CDB, where is that? That's right here. So, C to D to B. To find that angle, C to D to B, that's this angle right here. We want to know that one. We'll put a little theta there. All right, to know that angle or find that angle, we need two sides. We already have one side, 7. Okay. We could find BC, but that's not going to be very helpful. But we could find BD. I mean, it would be helpful, but it's probably not going to be very easy. We'd have to find BD first. All right, so this side right here is the one that we need. And I would probably find that one just because it is a side that is also a side of this other triangle, ABD. So from A to B to D, that's another triangle, and we already have an angle in one side. So if we find this side using that triangle, then we can use it to come up with our angle CDB that we want. All right, so looking at the other triangle, maybe I'll just change colors here. We want to figure out what, knowing this angle is 47, we want to figure out what this side is so that we can use it to figure out that angle. In fact, I'm just going to leave it X. No need to call it something else. So we'll just call it X still. All right, so we're looking for this side here, which is the opposite side. And we have the adjacent side. It's the hypotenuse down here that we aren't relating with our two sides. So we have an O and an A. So that's tangent. So the first thing we're going to do is we're going to find a side. So we have to think back about how we find sides. So the tangent of 47 degrees is going to be opposite X over adjacent 18. Okay. Now again, this isn't a side. This is not an angle. So we have to do all that, set up our equation and solve, which means we have to multiply by 18, and X then is equal to 18 times the tangent of 47 in order to come up with that side X. So in our calculator, we're going to type in 18 tangent 47, and that is approximately 19.3. So this is 19.3 approximately. All right, now if that's 19.3 and I don't know this angle here, theta, then I can use this being the hypotenuse now, and this running right into this angle, so it's adjacent. Adjacent and hypotenuse is cosine. Cosine is adjacent divided by hypotenuse. So because we're looking for our angle, theta degrees, is going to be cosine inverse of adjacent to the hypotenuse. Adjacent is 7. Hypotenuse I have in my calculator, 19.3. All right, now I'm going to bring back my calculator here so I can, wait, cosine inverse of 7. So to do this, we're going to do second cosine, and then 7 divide. Now, I need that answer from before, like that answer right there. So I'm going to arrow up and I'm going to hit enter. And it will put that answer right there and put it in parentheses. And then I have it most accurate as I can get on my calculator. And it's 68.7. So that makes 69 degrees. So this angle theta is going to be approximately 68.7 degrees. Theta degrees will be about 69 degrees. All right. Example 6 I'm going to do in my part 2 video, along with a couple of problems from the homework, examples from the homework. So stay tuned. You can go ahead and hit the 18.4 part 2 next.